Hi, Vladislav. Welcome to TRAI. And
hi, Betel, and hi, everyone.
How are you?
Fine. Thank you for asking. Thanks.
And yeah, we can continue. You can share your screen and we can begin your presentation.
So I'm setting my screen on. You should start seeing that.
Yes, we are set now.
So Betel, thank you again for the introduction. And hi, everyone. My name is Vladislav Severa. I'm founder of education technology startup LearnerOn. And today I wanted to show you some highlights of how we are using machine learning use cases serving the learning of humans. And this will briefly be the agenda outline. Before I will dive into machine learning and data science and AI, I will briefly outline what LearnerOn is all about. We are the sort of platforms which are called learning experience platforms, and our goal is twofold. We want to serve learning in the corporate setup at scale, so we are able to serve tens of thousands of company users and learners at the same time, and we are business-to-business software as a service operation. But on the other hand, we are also here to serve the individual learning needs of our users. And typically these two goals, the learning at scale and the learning with paying attention to individuals, these are hard to reconcile, but we are achieving the reconciliation thanks to some of the AI use cases and AI support. And I will tell you in a minute which in particular. And before I do that, I will also show you what's happening under the hood of LearnerOn, what we practically do. We are integrating learning content from multiple resources. So the primary resource are the MOOC providers of professionally prepared courses, big names like Coursera or Udacity or Pluralsight are our content partners. But we are also integrating the content from completely free and open sources. And also we are integrating the internal learning content or knowledge items and knowledge materials from our corporate clients, from the companies which we are serving. And together, we are at the moment having in our catalog a couple of hundreds of thousands of learning items. And then what we do is we are making the life easy for our learners, and the content discovery should be really a pleasure with LearnerOn. So we are supporting the top-down learning assignment as is typical for traditional learning management systems, but we are also supporting different discovery ways via semantic search or discovering content via skill models. And we are also training our other learning recommender. And that will be one of the machine learning use cases I will show you shortly. And this is just the look and feel snapshot of how LearnerOn looks as a platform. So now I am getting into the data itself. So from now on, I will start sounding a little bit more technological. With a lot of simplification, our underlying data model is handling four major entities. Foremost is the user, that's the entity number one. And the user in LearnerOn, because we are a corporate learning platform, the user typically performs certain occupation or is playing a role in the organization. And to the occupation or to the role, there are the needed or essential skills and knowledge items which are defining or describing the role played by the user. And the user on our platform is interacting with the learning materials. So the user is either learning some learning material or reviewing it or liking it. And finally, there is also a relationship between the learning materials and the knowledge items, and there's the correspondence. Certain learning material is corresponding or supporting certain skill or knowledge. And for each of these highlighted entities, we are having at least thousands, if not hundreds of thousands of items per each. And now you imagine how the links between the items are multiplying. This heterogeneous knowledge graph is growing very quickly. So we are actually working with a large graph data. And when I speak about the machine learning use cases which we are utilizing, they are broadly falling into two different categories. The first category is utility machine learning use cases, those which are just supporting the smooth operation of LearnerOn. And the other category are the strategically really important ones, those which are defining the functionality of LearnerOn. So I will start from the utility machine learning use cases. And the very first example is actually utilization of natural language processing. So imagine what a typical learning item may mean. If that's an online learning material, it can have some of the forms like course, video, podcast, or learning pass, or article, or a couple of more. And what we need to get on each and every of the learning items is a couple of essential metadata items, like on what subject the learning material is, what is its semantic vector, what is the difficulty level. And for example, I will stop by the difficulty level when you're having an article which is educational and which is available somewhere on the web. Nowhere on the article is written for what proficiency or difficulty level the article actually has been written. So we need to infer this missing metadata. And as an input, as the data available by default, the typical input is just the text of the learning material or full text of the learning material. So we need to get from the data available, the textual data, into the metadata space. And we do it with the following pipeline. At the beginning, we take the raw text and we are typically summarizing that to get it into shorter version. Then the text gets embedded. And on top of the text embedding, we are running classification or regression workload or whatever workload is necessary to arrive at the desired metadata. So this is a lot of natural language processing using most of the time transformer architectures for the raw data processing. Second example of the utility machine learning case I chose is from different angle. It's from image generation. And as we are handling hundreds of thousands of learning items, for some of the learning items, we are having naturally or natively given thumbnails or icons, but for many of them not. And to make the platform aligned and to represent every learning item also by the pictorial sketch, we utilized the recently released Stable Diffusion. So this is a screenshot from our search results. And I wonder whether by naked eye, you would be able to recognize which of these pictures was natively given and which is synthetically generated. So that's second example of the utility machine learning use case. And now I will make a step towards the more strategic machine learning use cases. So just to remind you, the underlying data structure is heterogeneous graph. These are the entities in the graph and the relationships. And I wanted to show you two strategic machine learning use cases. The use case number one is semantic search. We need to infer the correspondence between learning materials and the skills and knowledge items. And if we have hundreds of thousands of the learning materials and tens of thousands of the skills and knowledge items, the potential links can count to billions. And we are not able to pre-compute in advance all of these potential relationships. So it's done in real time, on the fly, via the semantic search. And the semantic search, as you may know, works the way that we are embedding the text description of the learning material, embedding also the textual description of the skill item, and then we are storing the resulting vectors in a vector database, which is specifically tuned to perform the nearest neighbor search in real time. So this is how our semantic search is working. And in different angle, different domain of the graph, in the interactions between user and learning materials, we are training our learning recommender. It's done in very similar way as we are used to Disney Plus or Netflix or Amazon, where these media platforms are asking us or suggesting what should be the next item we should watch or buy. So in very similar way, we are training our learning recommender. We are utilizing basically two approaches. One is very classical, that's collaborative filtering, looking at the past path of a user, watching or learning certain items, comparing the user to other similar users and recommending the items which the other users have also seen or learned. But there is a more up-to-date and modern approach. This is which is working with the graph or node embeddings. That's the domain of the graph neural networks, of the geometric machine learning, which you may have heard of recently. And all these workloads are working on top of a graph database. In our case, that's Neo4j, where we are storing the essential data. And then for actually the calculations, we are using two devices. One is Cypher, which is the query language on top of the graph database and can perform a lot of the essential calculations. But then the deep learning or the graph neural networks learning is done in PyTorch geometric. So that's our technology stack, which we are using in the learning recommendation space. And I also wanted to highlight a couple of the further AI use cases under construction, which are not finished yet and which are here and there tough cookies, but we are working on. And one very interesting one is learning path. Learning path is the unit of learning, which consists of a sequence of learning materials. Typically, if you are starting from your current state of knowledge and you want to get to some desired goal, you need to go through a couple of learning materials. One will not cut it. You will need to have a couple of, and you're starting from the basic one, where you learn the basics, and then you build on top of that knowledge with a second material, and etc., etc. And the order of the learning materials needs to follow the prerequisite relationship. And at the moment, the prerequisite relationship is being inferred by humans. So learning paths in LearnerOn are being curated and composed by humans. They are also intelligent beings, so the learning paths are of high quality, but eventually we want to automate the creation of learning paths. And for the automation, in the catalog of our learning items, this is a subset of the learning items, we will have to be able to infer the prerequisite relationship automatically. And this is a tough cookie. We are at the moment somewhere in the middle of the way. We are a lot playing with topic modeling and other tools which can get us to the ultimate goal, but this is something that is still work in progress in Learner. And the last use case, which is also under construction, I wanted to highlight, is creation of microlearning, which would be done in real time. Microlearning is the thing that you as a user raise certain query, you want to learn something, but you have only very limited time for that, only 5 minutes. And therefore, the resulting learning material shouldn't be longer than something like 200 of words. And then you want to get the output in real time. And at the same time, we as a learning platform are having lots and lots of learning materials, but long form learning materials, nothing like 5 minutes on hydraulic fracking. So the task would be from the long materials to get these short materials. And some of the building blocks would be natural ones like automatic summarization or Q&A answering, but these two things will not cut it. We need to add more into the architecture. So we are now also working with the reader and retriever architecture. We are not yet fully done, but we are somewhere on the way towards the desired goal. And the desired goal is obviously to serve our learners and users the best way possible. So that's the goal of LearnerOn as a company. Regarding Turkey, I have had already a couple of discussions with potential Turkish counterparts. I would be the most happy if I could have more. So whomever would be interested in getting in touch, these are my coordinates. And besides that, Bertil, thanks a lot for inviting me, for having me here. And it's a great event. So congratulations and thank you for attention.
Yeah, thank you. Thank you, Vladislav. It was a really great presentation. So even the NLP is like both very local, and also the topics that we have been covering is very common, that since we are talking Monday, like that they are very common things. And thank you for your presentation. And now we have a 15-minute break before the Canadian session begins. And we are going to take a cup of teas and coffees and relax before the Canadian sessions. Yeah, thank you.